Good morning, children. It's Sanjeev Pal from Srimati LPSAVANI VIDHYABHAVAN, your statistic educator, welcoming you all to the class of statistics. Hello, children. Here now we are on to our third chapter, measures of central tendency. Right now, here in this chapter, what we are going to study, we are going to see the introduction part of measures of central tendency. Right, we have seen in statistics, we learned the basics of statistics. What do we mean by statistics? How we collect the data, how we basically classify them. We even saw that how it could be analyzed. We even saw that how the data could be take up together and how the tables are being made, how the graphs are basically being drawn. Here basically we are going to see further what are the different measures that can be studied to actually analyze our collected data in a more statistical and in a more advanced manner. So over here we are going to see what do we mean by measures of central tendency. Here we are also going to talk about what are the characteristics of a good measure of central tendency, its meaning, advantages and disadvantages of mean. Over here as measures of central tendency, we are going to learn the mean, median and mode. We are also going to study about its advantages and disadvantages of mean. We will also see what do we mean by combined and weighted mean, what do we mean by geometric mean, right, and also say the positional averages, where we are going to talk about say the median. We are also going to talk about the quartiles, deciles and percentiles, also its advantages and disadvantages, and at the last we are going to see what do we mean by mode and comparative study of all the basic measures of central tendency, that is mean, median and mode. Okay, why we are studying the measure of central tendency? You have found out that till our last chapter, what we studied, that how to collect the data and how to make it more say concise and try to get the information from that. But if you want to get more information so that your analysis could be more precise and say accurate, we need to study and use the measure of central tendency. Now, measure of central tendency, I would try to take one example first and try to explain what do we mean by central tendency and the measure of central tendency. Now, suppose you are selling two different types of products, say product A and product B, right? And you have say the sales data of last 50 days, right? Now you want to compare how your sales are going through. So what you will do is that obviously you are going to collect the data of the last 50 days and you are going to analyze your data. As you will find that your data would be mingling around certain variable, right? Your data would be mingling around, or you can say concentrated around a certain variable. So over here you would find say as it is given over here that the characteristics of the data is actually called what is called the central tendency. That as you will draw these values onto the graph, you would find a certain characteristic, okay, into your data that you have collected for the last 50 days and that you are analyzing. Okay, so such characteristics of the data can be regarded as what can be regarded as the central tendency, and you would find the central value around which these variables are concentrated is called what is called the measure of central tendency, right? There would be a value around which all these data are concentrated. That particular value is regarded as measure of central tendency or the average, right? So that is what measure of central tendency is all about. You would find that in measure of central tendency, or say because of central tendency, you would find all the data you will find in a more concise manner. You will also able to find out the different characteristics of the data, and measure of central tendency also helps you to actually compare your collected data. That is why the measures of central tendency is so important. Okay, we talked about central tendency. We also talked about measure of central tendency. Over here, we are going to see what are the features or the characteristics of good measure of central tendency, or we can say how your ideal average should be, right? Okay, so see over here the first point. What they given over here, that it should be well defined and rigid. That your measure of central tendency, or you can say ideal average, should be very much clearly and in a simple way well defined, and also it should be rigid, that the value should have a concrete value. The value should be a concrete one. See the second characteristic or feature, that it should be easy to understand and calculate. Your measure of central tendency, or you can say your average, should be such that it is easy to understand, right, and also easy to calculate, that you are able to calculate the given average very easily, and even the people can also understand, okay, its value, how to actually calculate, and its importance. So that is the second characteristic of an ideal average. See the third one, it should be based on all the observations of the data. Yes children, while we talk about, say, the measure of central tendency, you would find, or you can say of an average, okay, you would find all the datas are used in its calculation. Okay, there shouldn't be any kind of data that is actually set aside. In your good average or an ideal average, you would find all the observations should be in use. So when all the observations are used, we can say that the average is having, is very well defined, and is having a good characteristic, right? Come to the fourth point, that it should be suitable for further algebraic operations. Yes children, your average should be such, or your value should be such, it should be basically concentrated upon the whole data in such a way that for further algebraic calculations, okay, or for further algebraic operations, it can be usable, right? See the fifth one, that it should be a stable measure. It means the value of the averages found for different samples of the same size from the same population should be almost the same. You would find that while we talk about, say, the average, or while we talk about, say, the measure of central tendency, it should be very much stable, that whatever the averages you have found, okay, getting the samples, okay, of the same size from the population, it should almost be the same. It means what, that from the population, if from the same different areas you have actually taken up different samples and taken out the average, the averages should be almost of the same value, then such a measure can be regarded as the ideal one, right? Come to your point number 6, that it should be say unduly affected by a few very large or very small observations. You would find that your ideal average should be such that even though in the data there are very large values or very small values, your average shouldn't get affected, your average shouldn't get negatively affected, right? When it is so, we can say that it is having a very good characteristic of an ideal average. So over here, while we are talking about, say, the average, or while we are talking about the measure of central tendency, what we are going to study, we are going to study the mean, median, and say the median, where we are also going to see median, that is positional averages, and also we are going to talk about, say, the mode. So mean, median, and mode, what we are going to study in actually measures of central tendency, and these are the above are the characteristics, or the above are the characteristics in an ideal measure of central tendency. Okay, now here we shall see what do we mean by arithmetic mean. As the definition of arithmetic mean goes, what has been given over here, that is, the arithmetic mean is defined as the value obtained by sum of all the observations divided by the total number of observation. So what do we mean by arithmetic mean? That whatever the observations are given to you, you do the summation of all the observations, right? And whatever the value you get later on, you divide it by the total number of observation, and the final answer that you get, that is actually your arithmetic mean. Now while we talk about arithmetic mean, you would find the arithmetic mean is symbolically shown as x bar. X bar is the symbol, you can say, by which you show what this arithmetic mean is. Right. Now over here you would find, children, that all the observations are given the symbol x1, x2, x3. So how it is basically being shown, the formula they have shown it like this way, that x1 plus your x bar is equal to x1 plus x2 plus x3. It goes till the n number of observations, you add them, and that summation that you basically divide it by the total number of observations, which is actually denoted by small n. So you would find over here your while we talk about the formula for arithmetic mean, this is the basic formula for arithmetic mean. That is, you can say your x bar, that's the symbol of arithmetic mean, okay, is its formula becomes your sigma xi upon n. Its formula becomes sigma xi upon n. Now what do we mean by sigma xi? Your sigma xi is the total of all the observation. And what is your n? Your n is actually the total number of observations. That is how your arithmetic mean is defined, right? So that is what arithmetic mean is all about. Now we shall see our first example. What has been given in our example number 1? That the following data show the number of scooters repaired daily at a garage, right? What they given, find the mean number of the scooters repaired per day. Over here, children, they have given that every day how many number of basically scooters are being repaired, okay, in a garage, and we need to actually give that on an average. Okay, what we need to have over here, we need to have that on an average per day how many scooters are being repaired. So over here you would find, children, the value they have given basically 8 values, right? As they have given 8 values, okay, you would find that our n becomes 8. Okay, they have given that on the first day 7 number of scooters are repaired, second day 13 number of scooters, third day 4 scooters, then 8, 6, 9, 10 and 4 scooters. That is on different days, that is in 8 days, that a different number of scooters are actually being repaired, right? Now as we have seen that what do we mean by mean, we have seen that our x bar, as far as the formula goes, okay, we have seen that our x bar is equal to what, our sigma xi upon n. We have seen our sigma xi is equal to what, is equal to the total of all the observations. So over here you would find, children, that all the observations are basically being added. Okay, over here you are able to see actually the minus sign, but it is not minus, it is the addition sign, right? So all the observations, that is from 7 to 4, they are being added and it is divided by the total number of observations, right? So as you will add all these observations, you would find the total is coming up to say 61. The total is coming up to say 61. The total number of observations given over here is 8. As you divide into the calculator, you would get 7.625, or it might be even more than that. But you need to write up to 2 decimal places, and that's why, because the third decimal place is 5, and if it is more than 5, you would just add a number to the second decimal place. So your number by or up to 2 decimal places becomes 7.63, right? So you will write the answer up to 2 decimal places. So over here your answer is what, 7.63. Why 3? Because the third decimal is 5, and if it is 5 or more than 5, you will just add 1 to the previous number. So to this number 7.62562, you have added 1, so it had become 7.63. So you wrote the answer up to 2 decimal places, that is 7.63, right? So you would find over here, children, so what is the answer they have given? That is the mean number of scooters repaired per day at the garage is 7.63 scooters. And children, as you write the answer, it is really compulsory, you would say, you would find that you need to write the unit of the mean. Over here, what is the unit of the mean? The unit of the mean is scooters, right? That is the unit for your answer. You need to write the unit. Over here, the unit is scooters. So you need to show that the average number of scooters that is being repaired, okay, into the garage is 7.63 scooters, right? So that is your first example, right? That is actually your first. Okay, we saw the basic formula of arithmetic mean. Now we are going to see how this arithmetic mean is defined by shortcut method, right? While we talk about, say, the shortcut method of arithmetic mean, you would find what is actually this shortcut method, okay, to find out this arithmetic mean, right? So you would find over here, that your arithmetic mean, that is your x bar, is equal to your a plus sigma di upon n. Now what do we mean by sigma di? First of all, what do we mean by di? Di is actually defined as xi minus a. While we talk about, say, di you would find is defined as your xi minus a. Now what do we mean by a? Over here we are going to see, first of all, what do we mean by a. Your a is actually your say assumed mean. A is what? Assumed mean. That is, whatever the observations are given to you, from those observations you actually find out, or you take out such a central value, right? Okay, or such a value which is actually concentrated upon by the other values. Such a value can be regarded as what? Assumed mean. That is, you are assuming a value out of all the observations, okay, that it could be the mean of all the observations, and that is actually your a. A is equal to what? Assumed mean. So while as assumed mean goes, or while we talk about d is what? D is the deviation, right? So your di becomes what? Your di is equal to xi minus a. Xi, or you can say x1, x2, x3, all these are what? All these are the different observations, or different values, okay, from which you just deduct your assumed mean. Don't worry, children, as we will basically do the sums, you will get to know how to have this assumed mean and what is our sigma d. And while we talk about basically sigma d, sigma d, you would find sigma, that is summation. Sigma d, you would find that when all the deviations you just add, you get what? You get sigma d, right? So we will move further now. We'll see the example number 2 by shortcut method. You will come across how to actually use this shortcut method. Now what is the sum given to you? We will see the sum. See your example number 2. What has been given? The rainfall in mm. Right now, what is this mm? Mm is the unit of rainfall. So as you write your answer, it is necessary to write the unit, that is in mm. So the rainfall in mm at 10 different places. They have told 10 different places. So your n becomes what? Your n becomes 10. 10 different places of a district was recorded as under. Okay, now this is the rainfall of 10 different districts, that is 126, 110, 91, 115, 112, 80, 101, 93, 97 and 113 mm respectively, of, you can say, 10 different districts. Now over here you would find that the table has you need to prepare basically this table. Now if you see, children, all these values, see what are the values? 126, 110, there is 91 also, there is 80 also, there is even 101 and 113. So assumed mean, what they have taken? Assumed mean they have taken up as 100. The assumed mean they have taken up as 100. इसका मतलब क्या हुआ? ये जो सारे values है, all these values that you are finding, okay, are concentrating around this 100, right? And that's why 100 has been taken up as assumed mean, right? Now as I told you the formula for the assumed mean, assumed mean you would find it is xi minus a. Over here what we have taken, a has been taken up as 100. Now as far as shortcut method goes, what is the formula for a mean? Okay, the formula of mean by shortcut method is a plus sigma di upon n. Okay, the formula for mean by shortcut method is a plus sigma di upon n. Now first of all we are going to see what do we mean by di. ये di कैसे आया वो हम देखेंगे, right? So you would find as the formula goes, as we have seen the formula, that our di is, this you need to remember, that your di is equal to xi minus a. मतलब हम सारे ऑब्जर्वेशंस में से एज्यूम्ड मीन का वैल्यू जो है वो डिडक्ट करते जाएंगे. मतलब सारे ऑब्जर्वेशंस में से एज्यूम्ड मीन का जो वैल्यू है वो डिडक्ट करते जाएंगे. तो व्हाट विल हैपन ओवर हियर, यू वुड फाइंड, सी द फर्स्ट ऑब्जर्वेशन, that is you can say your 126 minus your 100, okay, you would get 26. Similarly 110 minus 100, 10. 91 minus 100, okay, sorry, yes, 91 minus 100 will be minus 9. Then 115 minus 100 will be 15. 112 minus 100 will be 12. Say similarly you would find over here, as we move on, okay, you would find that your 80, right, your 80 minus 100 will give you minus 20. Your 101 minus 100 is equal to 1. Your 93 minus 100 will be minus 7. 97 minus 100 will be minus 3. And 113 minus 100 will be 13, right? And as you add all this deviations, that is d, okay, as you add all this d, that is your sigma di. इन सबको आप ऐड करोगे तो आपको क्या मिलता है, sigma di, and you would find the total of sigma di has come up to 38, So now the time to actually find out the mean by the shortcut method. Over here n is 10, because over here they have given you the rainfall of 10 different districts, that's why n is equal to 10. I have told you that what is the formula for mean by the shortcut method, that is your x bar is equal to a plus sigma di upon n. A assumed mean, okay, we have taken the assumed mean as 100, right? So over here you are going to have 100, right? Then you would find sigma di, we have got the total of sigma di, that is 38. Our n is what, our n is 10. So first of all, now what you are going to do further, as you will do the calculation, you will solve this fraction first, that is 38 divided by 10 will give you what, will give you 3.8, and as you do this further, calculate this further, you get 103.8, and that is actually your average rainfall. 103.8 is the average rainfall for this 10 different places. 103.8 mm actually is the average rainfall for this 10 different places, right? So this is your sum by shortcut method, right? Now further sums, children, we will see in our next video. Okay, so bye for now. Thank you very much, and God bless you all.